Welcome to the coordinate geometry, lecture number 12. Dear students, yesterday we finished our question number 3 of exercise 5.1. Now I am going to begin with next question, that is question number 4. In this question, they have given vertices of the triangle as P minus 2, then Q 2, 2 and R 2, 7. And question asked is verify whether these are the vertices of right angle triangle or not. Now since you all know the property of right angle triangle, that hypotenuse square is equal to one side square plus other side square. Hypotenuse is always a larger side. So what I will do now, I will find out the distance PQ, then I will find out distance QR, and then I will find out distance PR. Then I will see that the square of the largest side is equal to sum of the squares of other two sides or not. So let's find out distance PQ first. I have labeled the coordinates of P as x1 y1, while coordinates of Q as x2 y2 and coordinates of R as x3 y3. Now I am going to find out distance PQ. Now by distance formula, you all know PQ is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Then I will substitute values. That is equal to value of x2 is 2, so I will write here 2 minus value of x1 is minus 2. So as I explained to you yesterday also or in previous lecture, whenever the coordinate is with negative sign, we must put a bracket for that. So minus 2 into minus 2 the whole square plus value of y2 is 2 minus 2 the whole square, 2 minus 2, that is y2 minus y1 the whole square. So next simplification is as such, 2 plus 2 makes it 4, so I get here 4 square plus, try to understand, minus into minus makes it plus, so therefore I got it over here 4 square, 2 minus 2, obviously it is going to be 0 square. So next to that you will be getting 4 square is 16. So therefore value of PQ is equal to 16 units. Now as I obtained the value of PQ, now I am going to find out value of QR by same formula. So for finding out QR is equal to square root of. Now the second point is coordinates of our x3 y3. Same formula, but I will use it in the way x3 minus x2 the whole square, x3 minus x2 the whole square plus y3 minus y2 the whole square. The next step is to substitute values. Now value of x3 is 2, so I write here 2 minus value of x2. Value of x2 is also 2. So 2 minus 2 the whole square plus y3 minus y2. Now y3 is 7. 7 minus 2. 7 minus 2 the whole square. That will give you the next step as 2 minus 2 is of course 0. So here we will find 0 square plus 7 minus 2 is 5 square. So our distance QR is equal to square root of 5 square is 25. So here I obtain the value of QR as 25. So I know the value of PQ, which is root 16, as well as I got the value of QR as root 25. Now I'm going to find out value of PR. So let's find out value of PR. PR is equal to, by distance formula only, R is the next, or I can say it's the second coordinate. Therefore, x3 minus x1, the whole square. x3 minus x1, the whole square, plus y3 minus y1, the whole square. That will give us square root of x3. Value of x3 is 2, while the value of x1 is 1. We have to be careful here also. So I'll write it in here as 2 minus of minus 2. So 2 minus of minus 2, bracket close, the whole square, plus y3. Now you will find y3 is 7. 7 minus 2, the whole square. 7 minus 2, the whole square. So next step is, that is equal to 2 minus of minus, of course it is plus. So 2 plus 2 is 4. So I'll get here 4 square plus 7 minus 2 is 5. So 7 minus 2 is 5. So that is 5 square. So this is how PR is equal to 4 square, the root of 4 square plus 5 square. Now PR is equal to root of, since you all know 4 square is 16. So 16 plus 5 square is 25. So therefore we get PR is equal to root 41. Now you will notice one thing, dear students, that value of PR I obtained it as root 41, and of course PR is greater than PQ, as well as PR is also greater than QR, because value of QR is root 25 while that of value of PR is equal to root 41. So since we all know the property of right angle triangle, hypotenuse is the largest side and square of the hypotenuse is equal to sum of the squares of other two sides. So I am going to verify PR square is equal to, let us verify, Pythagoras theorem. Let us verify Pythagoras theorem. That will give us PR square is equal to QR square plus PQ square. So in this case, you will find value of PR, which is root 41. I write it over here as root 41, the whole square, that is equal to value of QR is root 25. So I write it as root 25 the whole square plus value of PQ is root 16. So I write over here root 16 the whole square. That will give me square of any square number is that number itself. So I'll get over here 41 is equal to 25 plus 16, and surely find 41 is equal to 41. So by converse of theorem of Pythagoras, we'll get triangle PQR is a right angle triangle. So finally you must mention over here as by converse. By converse of Pythagoras theorem. is right angled triangle. So this is how you will find. First of all, I find out value of PQ, then I find out value of QR, and later on I find out value of PR. After finding out these values, I came to know that value of PR is the largest one. So by property of Pythagoras theorem, since you all know hypotenuse is the largest side, so I got it as PR square is equal to PQ square plus QR square. So this is how you will find that we prove over here that it is a right angle triangle. Now let's do the next sum. Our next sum is question number 4. In this question number 5. In this question number 5, they ask us, what they ask us to find out? They ask us to find out or verify that given quadrilateral is a parallelogram. Now in this case, since you all know the property of the parallelogram as far as length is concerned, that opposite sides of the parallelogram are always congruent, or with respect to the distance formula, I can say the length of opposite sides are same. So if we prove that opposite sides of this quadrilateral are congruent, then actually I will get quadrilateral, or I can prove quadrilateral as a parallelogram. So please see here, there is no need to draw a figure in examination, but for your convenience I am going to draw a figure. There are no marks are there for this figure at all. So you will find that P2RS, simply for sake of convenience, here I have drawn. So you will get the coordinates of P as 2, minus 2. Then you will find the coordinates of Q are 7, 3. Then you will find coordinates of R are 11, minus 1. And coordinates of S are 6, minus 6. And you have to prove that question number 5 show quadrilateral PQRS is a parallelogram. So we have to prove here quadrilateral PQRS is a parallelogram. Since I have explained you earlier, there is no need to draw figure. This figure is not carrying marks at all. Now I am going to prove. What I have to prove? PQ is congruent to SR. Now PQ, I will label this 2, minus 2, and Q 7, 3. I am going to label them as x2, y1, and we will find x2, y2. Now by distance formula, you will find, I find out length PQ. So length PQ is equal to square root of x2 minus x2 the whole square, x2 minus x1 the whole square, plus y2 minus y1 the whole square. That is equal to coordinates of P 2, minus 2 x1 y1, coordinates of Q 7, 3 x2 y2. By distance formula, x2 minus x1 the whole square plus y2 minus y1 the whole square. So x2 minus x1, 7 minus 2, 7 minus 2 the whole square, plus y2 minus y1. Be careful here. Y2, coordinates of y2 are 3, so 3 minus of minus 2. So minus of minus 2 the whole square. So that will give the next step as square root of 7 minus 2 is 5 square plus 3 minus into minus makes it plus. So minus into minus is plus, 3 plus 2 is also 5. So here also I got 5 square, there also I got 5 square. Therefore PQ is equal to value of PQ, I will get it as that is equal to root 5 square is 25, here also 5 square is 25. So I obtain the value of PQ as root 50. Dear students, you may feel that split this 50x, 25 twos up, then take 5 to it is 1 and the same, but for time being I am going to give PQ as root 50 only. Now let's see, I am going to find out SR. So I label it as x1 y2, x2 y2, x3 y3 and x4 y4. Now since I got the value of PQ, I am going to find out value of SR. I will call it as equation 1. Now I am going to find out RS. So you will find that coordinates of R 11 minus 1, 11 comma minus 1, while that of coordinates of S are 6 comma minus 6. So x3 y3, x4 y4. When I say RS, naturally you will find S is a second point. So length of RS is equal to length of RS. Second point is S. So I take it as x4 minus x3 the whole square plus y4 minus y3 the whole square. That is equal to, substitute the values. Now you will find x4 is 6. So I will take it as 6 minus x3. What is the value of x3? 11. So I will take it as 11 whole square plus value of y4. Value of y4 is minus 6. Be careful again here. y4 minus of minus 1. Very important. Square over here. So that will give us 6 minus 11. You know, 11 is a larger number. From that we have to subtract the smaller number and we always place the sign of the larger number. So you will find 11 minus 6 is minus 5 the whole square. Then plus minus 6 plus 1, that is also minus 5 the whole square, because minus into minus is plus. So we will find here square of any negative number is also positive. So minus 5 square will give us plus 25, while that of minus 5 square in this case is also 25. So length of RS, here length of RS is equal to root 15. This is equation number 2. Since we have to prove quadrilateral PQRS as a parallelogram, so what we have to prove? Opposite sides are congruent. So in this case you will find PQ and RS are opposite sides, but it is not enough to prove only one pair of opposite sides is congruent, but we also have to prove the other pair of opposite side is also congruent, and therefore at least for time being I can write it as PQ is equal to RS, that is equal to root 15. So this is result number 2. Pair of opposite side. Pair of opposite sides. So this is how we prove one pair of opposite sides is congruent. Now I am going to prove other pair of opposite sides is also congruent. Now let's see here. You will find, now I am going to prove PS. I am going to find out value of PS. You will notice over here, dear students, that I have labeled PS as coordinates of P are x1, y1, while coordinates of S are x4, y1. So you will find over here that I am going to prove pairs of opposite sides are also congruent. So let's see here. Coordinates of this is root 50 and this is also root 50. Again, I would like to tell you there is no need to draw figure. Only to get you proper explanation, I have drawn the figure. So here you will find coordinates of P are 2, minus 2, x1, y1. Then coordinates of S are 6, minus 6, x1, y1. Coordinates of X are x4, y4. Now in this case you will find second point is S. So again divide distance formula only. So PS is equal to root of second point is S. So x4 minus x1 the whole square, x4 minus x1 the whole square plus y4 minus y1 the whole square. Okay, now what we do? We substitute the values. By substituting the values, x4 is 6 minus x1 is 2. 6 minus 2 the whole square plus y4 you will find it as minus 6 minus y1. So minus of minus 2. Every now and then I am reminding you the same thing. Whenever you will obtain any coordinate with negative sign, you must have to introduce bracket over there. So you will find over here root of 6 minus 2, that is 4, plus minus 6 plus 2. Try to understand these students. Minus 6 plus 2 the whole square. Minus 6 plus 2 is minus 4. So here we will get PS is equal to root of 4 square plus, here you will find minus 6 plus 2 is minus 4. Minus 4 the whole square. That will give us 4 square is 16 plus minus 4 square is also 16. So PS is equal to root 32. Same way as we have done in the previous case, labeling as 3. So this is how you will find I obtained value of PS as root 32. Now I am going to see what is value of QR. Now coordinates of Q are 7, 3. While that of coordinates of R are 11, minus 1. 11, minus 1. We have already labeled them as x2, y2, x2, y2, and this as x3, y3. Second point, here also you will find second point is point R. Okay. So I will see here distance QR is equal to x3 minus x2 the whole square plus y3 minus y2 the whole square. Same way, that is equal to, now x3. What is value of x3? 11. So 11 minus 7 the whole square plus y3 is minus 1. Minus 1 here minus 3 the whole square. Now since you all know, very simple, 11 minus 7 is 4. So 4 square plus minus 4 square. Same that of previous case. So here you will find 4 square is 16 minus 4 square is also 16. So QR is equal to root of 16 plus 16. So this is how you will get value of QR as root 32. Label this as 4. Label this as 4. Now we will find value of PS as well as value of QR. Each one of them are root 32. But PS and QR is forming the pair of opposite sides. So we can say PS is equal to QR, that is equal to root 32. This is reason P, pair of opposite sides. Pair of opposite sides. Now I will say, since the pair of opposite sides from result A and B are equal, or we can say they are congruent, and therefore quadrilateral PQRS is a parallel. Now I am going to say from A and B, pair of opposite sides are congruent, quadrilateral PQRS is parallel. So this is how you will find we prove the quadrilateral PQRS is a parallelogram, because you will find here that opposite sides PQ while that of RS are root 15 each, while that of PS and QR are root 32 each. Now I am going to do question number 6. For question number 6, this time we have to prove that given quadrilateral is a rhombus. This time we have to prove quadrilateral given as a rhombus. Whenever we have to prove quadrilateral as rhombus, we need to prove all sides of quadrilateral are congruent. In the previous sum, you may think that quadrilateral PQRS may be a parallelogram as well as it can be a rectangle. Very important. The difference between the property of parallelogram and as that of rectangle is that diagonals of parallelogram are not congruent, while you will find diagonals of rectangle are congruent. But we don't have to worry about the property of diagonals, it is sufficient to prove that opposite sides are congruent. Now let's see here for question number 6. I'm going to write over here. You will find coordinates of A are -4, -7, while that of coordinates of B are -1, -2. Coordinates of C are 8, 5, and while that of coordinates of D are 5, -4. These are the coordinates of quadrilateral ABCD, and we have to prove quadrilateral ABCD as a rhombus. Prove that quadrilateral ABCD as rhombus. Now again, I am going to prove now all sides congruent. Okay. So here you will find, supposing if I call it as x1, y1, this I call it as x2, y2, this I call as x3, y3, and this I call as x4, y4. So I label the coordinates as x2, y1, x2, y2, x3, y3, and x4, y4. Let's find out. AB. Now what are the coordinates of A? -4, -7. And what are the coordinates of B? B are -1, 2. Call it as x2, y1, and this as x2, y2. Now distance AB, okay, by distance formula, distance AB is equal to root of coordinates of the second point x2, y2, same formula, x2 minus x1, x2 minus x1, the whole square, plus y2 minus y1, y2 minus y1, the whole square. That is equal to x2 minus x1. You will find coordinate of x2 is -1. Okay. Coordinate of x1 is -4. Again, you have to be careful. Minus of -4. Very important here, students. Plus coordinate of y. y2 is value of y2 is 2 minus 1 minus of -7. The whole square. That will give us the next thing as -1 minus into minus is plus. So -1 plus 4, the whole square, plus 2 plus 7, the whole square. Try to understand again. -1 as it is, minus into minus is plus, so 4 minus 1 the whole square, and 2 plus 7 the whole square. So next thing, value of AB is equal to, so value of AB is equal to, you will be getting over here 4 minus 1, very simple, it is 3 square, 3 square plus, next to that is 7 plus 2 is 9. 7 plus 2 is 9. Whole square. Therefore, AB is equal to root of 3 square is 9 plus 9 square is 81. Of course, you will get value of AB as root 90. In this case, dear students, we have to find out value of all sides. So AB, we obtain it as root 90. Now let's find out, after finding out AB, I am going to find out BC. Now value of BC. Coordinates of B, second part. Okay? Second part. Coordinates of B are minus 1 comma 2. So minus 1 comma 2. One vector of coordinates of C are, okay. So coordinates of C are 8, 5. 8 comma 5. I have labeled B as x2 y2. So right here x2 y2. I have labeled C as x3 y3. So right here x3 y3. The same by distance formula only. So distance BC is equal to root of coordinates of the second point. Now second point is what? C. x3 minus x2. x3 minus x2 the whole square plus y3 minus y2. y3 minus y2 the whole square. That is equal to root of. Now let's substitute the values. The value of x3 as 8 minus value of x2 is minus 1. Again you have to be careful over here. Minus of minus 1 the whole square plus y3. Now what is value of y3? y3 is 5. 5 minus 2 the whole square. That will be root of 8 minus into minus is plus. So 8 plus 1 the whole square, because you will find minus into minus becomes plus. 5 minus 2 is 3 whole square. Now I will get the value of BC as value of BC is equal to value of BC is equal to 8 plus 1 is 9, and 9 square you all know is 81. So 81 plus 3 square is 9. So 81 plus 9, I will get value of BC as root 90, the same value as that of AB. So I write here BC, equation number 2. Now I find out value of AB. I also find out value of BC. Now I am going to find out value of AB, BC, and actually now CD. So coordinates of C. Coordinates of C are 8, 5. So coordinates of C are 8, 5. While that of coordinates of B are, will find 5, minus 4. 5, minus 4. I have already labeled C as x3, y3. So here x3, y3 and coordinates of D, I have labeled them as x4, y4. So x4, y4. You will simply find it again. CD is equal to root of distance formula only. Now root of second point is D, having the coordinates as x4, y4. So x4 minus x3 the whole square. x4 minus x3 the whole square plus y4 minus y3 the whole square. That is equal to root of x4. What is value of x4 over here? 5. Correct? So 5 minus 8 the whole square plus y4. y4 is minus 4. So minus 4. You will find 5. That is minus 5 the whole square. Next step will be 5 minus 8. 5 minus 8 is of course minus 3. So minus 3 square plus minus 4 minus 5 will give you minus 9. So I am going to continue the same things over here on this board. Please have a look at this board for some while. Now you will find, I am going to find out value of CD. I am finding here value of CD. To get the value of CD, very important over here, that CD is also, you will notice the same thing, minus 3 square is plus 9, while minus 9 square is of course plus 81. So 81 plus 9 is equal to root 90. So next step is CD is equal to root 81 plus 9, that is equal to root 90 CD. So this is how you find the length of third side. Length of third side, which is CD also, we got it as root 90. Now only one side is left out, which is that one, AD. Now I will write it again. Coordinates of A are minus 4, comma minus 7, and while the coordinates of D are 5, comma minus 4. So coordinates of A, we have taken them as x1, y1. While coordinates of B, we have taken them as x4, y4. x4, y4. Again, we use the distance formula only to find out value of AD. AD is equal to root of second point is D, and coordinates of D are x4, y4. So naturally, I write it as x4 minus x1, x4 minus x1 the whole square plus y4 minus y1 the whole square. Same way as we have done in previous cases. So AD is equal to, after writing formula, our next step is to substitute the values. Now value of x4 is 5 minus x1. Again x1 is with negative sign. So minus of minus 4 whole square plus y4 minus y1. Now y4 is minus 4. Minus 4. y1, be careful here, minus of minus 7 the whole square. So we will get over here the next step. Value of AD is equal to root of, value of AD is equal to root of 5 minus into minus is plus, and 5 plus 4 is 9. Please try to understand, dear students, here. 5 minus into minus makes it plus, and 5 plus 4 is 9. So 9 square plus minus 4 plus 7. Minus 4 plus 7 the whole square. So that is equal to 81 plus 7 minus 4 is naturally 3. So 7 minus 4 is 3 square. So here you will get 81 plus 3 square is 9. So 80 is equal to root 19. This is our equation number 4. So, what result we get? We get result from 1, 2, 3, and 4. From 1, 2, 3, 4, we get it as AB is equal to BC is equal to CD is equal to AD is equal to root 90. So all sides are congruent, and that is what we have to prove. So we can say the next statement is, since all sides of quadrilateral ABCD are congruent, quadrilateral ABCD is a rhombus. Is a rhombus. So this is how you will find that we labeled the coordinates as x1, y1, x2, y2, x3, y3, x4, y4. Then I find out value of AP, BC and CD as well as AD. And I got values of all these sides as root 90. Therefore, quadrilateral ABCD becomes a rhombus. Dear students, here I have finished my lecture number 12. See you in the next lecture. That will be lecture number 13. In that, I will the next sum, that is question number 7. Thank you.